Welcome back to SEEK Bytes, the podcast for engineers by engineers. On this episode, we're talking about clean architecture with the head of engineering for monetisation at SEEK, Adam Kreitals. We touch on what is clean architecture and why is it important? How does it differ from other architecture patterns? How to sell your team on adopting clean architecture? Why Adam's Slack profile picture is a horse in a hat? And plenty of advice from our lived experience with architecting software.
Welcome back to the podcast. We've got a very special guest. Adam, tell us who you are, what you do here, and why you have a horse with a hat as your Slack profile picture.
God damn, that was good.
I was not expecting that question. Firstly, thanks for having me. My name is Adam Kreitals. I'm the head of engineering for our Monetisation and Insights domain here at SEEK. Do you want a bit of background in terms of how we fit into the business? So SEEK is a marketplace. We connect talent with hirers, with job opportunities. I sit on the hirer side of that marketplace, and I'm the head of engineering across the teams that look after our purchasing flows, our products, pricing, discounting, sort of the money side of, we like to call it the money side of hirer. So there's 4 teams there. I've been in this space since I started at SEEK, 5 or 6 years ago. So it's a place I know well.
Did you come in as the head of engineering?
No, I came in as a principal engineer back when we had principal engineers. So I've sort of been through principal engineer, senior principal engineer, engineering manager, and then into head of engineering, but all within that space. So I've seen it grow from 5 or 6 engineers, 5 years ago to where we're at now, which is about 50 odd engineers.
It's a lot bigger now, yeah, for sure. Awesome. So we've got Adam on the podcast today to talk to us a little bit about a topic that I'm very passionate about, which is clean architecture and more broadly software architecture in general, because Adam is the person that introduced me to clean architecture, and it's played a pretty significant role in the way that I think about software problems and how we approach them. So I thought it'd be really good for us to have a little bit of a conversation around, I guess, the pros and cons and some of our lived experience with this pattern and other patterns like MVCS and stuff like that. Adam, it might be good to start with, like, how did you first encounter clean architecture and what drew you to it? Was it a pre-existing architecture in a team that you joined, or did you find it and then introduce it? How did that happen?
Actually, it was a bit of both. So how did I get introduced to it? So thinking back to my early days with Node, effectively, so thinking back to 2011, 2012, I had experience with frameworks like Spring in Java and Symfony in PHP, and had started exploring Node. And at that time, there was kind of some emerging frameworks in like Happy and Express, so it should be around that 2011, 2012 timeframe, and being a little bit underwhelmed with the structure that, and admittedly they weren't trying to solve these problems, but a little bit underwhelmed with the structure that I was seeing coming out in the Node community at that time. It was new. A lot of people had been moving from, like myself, had experience with JavaScript on the front end. It's like, okay, how does this apply to back-end applications? Maybe looking at trying to apply some of the same practices and patterns, and starting to realize pretty quickly that they don't necessarily fit the way that I would like them to, particularly when it comes to how we structure and evolve our software, which is really what this is about. I was familiar with Uncle Bob through his Clean Coder book, but also a Clean Code book. So I'd read those, and there was a blog post that he put out, I think it was about 2012, somewhere around 2012, introducing clean architecture. The book followed.
So let me just stop you right there. Who's Uncle Bob, for those who haven't heard of Uncle Bob?
Rob Martin, he's known as Uncle Bob. So he's the author of Clean Code. Is probably his most famous book. I think most engineers and most junior engineers will be pointed in the direction of that. It's a great book. He's had a blog called The Clean Coder for some time. I would suggest he's a bit of a thought leader across the space, but he's very focused on how we can create evolvable architectures and code that sort of stands the test of time.
Is that what clean code and clean architecture is? code that can stand the test of time? What is kind of the definition of that?
What is clean architecture? The way that I would describe this is it's an approach to software or to developing software that emphasizes separation of concerns, so it focuses around coupling and cohesion, and presents some principles and some ideas that should allow us to evolve our code more efficiently. So with less cost and at a greater pace. And so a lot of the principles around that's really what it centers on. And when we say architecture, we should probably define what that means as well. In this sense, it's not a code structure. It's not a set of hard rules. It's really some principles and some ideas that promote good practices when it comes to structuring our code and our architecture.
I just want to touch on two words you mentioned there in case people don't know what they mean. So you mentioned coupling and cohesion. So what are they? What do they mean and why are they important?
So coupling is the concept of one or more entities, components, modules being dependent on each other, coupled in some way. That could be through code, it could be through deployment, it could be through dependencies, but where they are coupled together in the sense that it's very hard to, or can be hard, to evolve one without having to make changes to the other. Cohesion being the concept that things that are highly cohesive will often change for the same reason, and if they are highly cohesive, there's a thinking here that they should probably belong together. So you're looking at decoupling things that don't change together and identifying those things that do change together and keeping them close.
And are those things, or like, if coupling always a bad thing? Is the idea to eliminate it completely, or is the idea to find the right balance of something that's coupled? And I don't know, is it always bad?
So it's not always bad.
Because I know for like a lot of microservice stuff, there's a lot, like particularly with sometimes type packages and stuff, like they're coupled together. Is that a bad thing?
It's probably better to say that you want to reduce unnecessary coupling, right? Because there's going to be, at some point, there's going to be necessary coupling. But you can design your code and your architectural code in such a way that there's dependencies that don't need to be there. Or like dependency inversion, right? Like the coupling is still there, but you've got two entities. You make entity B responsible for defining the contract rather than entity A, so you can invert the dependency.
Like I said, there's many ways of coupling things together, and some will make it harder to evolve than others. So being aware of what those different types of coupling are, how they impact your system and how it's going to evolve is really important. It's at any scale, even at a tiny scale, it's impossible to avoid any level of coupling. You can think about some examples like just utilizing frameworks. Like you're immediately, regardless of what sort of boundaries you put in place, there's going to be some level of coupling to that framework. In terms of our deployments, there's going to be some level of coupling to either the technologies we're using to deploy or the things that we're deploying together. But you're right. It's really about identifying like what is that coupling that's going to stand in the way of us being more efficient in the delivery of our value when it comes to software.
So you talked a little bit about clean architecture, emphasizing modularity, decoupling. We can get into that a little bit more, talk about dependency rule and the onion and stuff like that in a little bit. But I'm wondering from your perspective, what are some of the standout differences between clean architecture compared to other popular paradigms? And so for context for people, clean architecture is just made up of pre-existing ideas like hexagonal architecture, ports and adapters. It builds on a series of other concepts.
Dirty programming.
So there's definitely like some overlap with those ones, but there's architectural styles that are wildly different, like vertical slice architecture, like bundle by feature, that kind of thing, which you might say clean architecture is kind of in that bundle by feature bucket. But how do you think clean architecture differs from some of these other popular paradigms?
I think you've answered the question a little bit already, but let me just touch on that later bit. So clean architecture doesn't suggest that we need to bundle by feature or by layer or horizontally, vertically. It could apply to any one of those, and there's actually some good sections in the book that sort of explain some of the trade-offs around that. So it's not really about how we structure our code in those respects. It's about some of the principles we want to apply when making decisions around how we want to structure our code. But you're right in that, it is a combination of, or it's an evolution, I guess, on some of those architectures that have come before us. If we sort of think back to, EBI from Ivar Jacobson, taking this idea of boundaries and then entities and creating a domain-centric design. You mentioned ports and adapters and creating that boundary to externalities that Uncle Bob will call details, external details, creating that boundary so that your domain logic is separate. Even MVC and separation of presentation, you mentioned that a little bit earlier on. It's taking that idea of separation of presentation. So it's building on all of these ideas. MVC, sort of late 70s, all the way through to Jeffrey Palermo's onion architecture and the idea of this is where there's a lot of dependency rule that you mentioned comes from. That was sort of what, I don't know, 2010, somewhere around there. So it's sort of this evolution and bringing together a lot of these ideas, which were all centered around the same concept of separation of concerns, right? And if we think back to Solid and the single responsibility principle, it's kind of a higher level abstraction of that single responsibility principle applied at a module or a component level.
Solid. Everyone likes solid coding, but what does solid even mean?
Solid is an acronym of 5 principles. So single responsibility principle, open closed principle, Liskov substitution principle, interface segregation principle, and eversion of dependency principle.
It's just a pop quiz in here, really. That's
It is like, what is that acronym? What does that mean?
spell Qantas.
It's good that we mentioned Solid because it's often used as like the benchmark for success when you're applying any kind of architecture, generally, right?
It's a great set of principles to, again, point us on the right track to the way that we're structuring our code. That's at a little bit of a lower level, and in Uncle Bob's book, he introduces 5 more principles. So there is a whole chapter on Solid, or is there multiple chapters on Solid? I think there's multiple chapters on Solid. And then he introduced 5 more principles, 3 around coupling and 2 around cohesion, or the other way around. So it's kind of building on that idea, and you'll see with probably, I would say, the most important principle that he introduces around the common closure principle is essentially single responsibility principle, just evolved to a component and module level. So understanding Solid is, in my opinion, a really great stepping stone towards understanding a lot of the reasoning and the motivation behind the principles and what underlies clean architecture.
When we're talking single responsibility, that's one thing should do one thing, sort of, right? But I find sometimes people take that, particularly now with microservices and stuff, people think, well, we now need a separate service that does that one thing, as opposed to just understanding, well, things can kind of be together and still, be separated in a way where it still does that one thing. Do you feel like these principles sometimes get misconstrued for how they should be done?
Absolutely. They're principles, not rules. The way that we choose to apply them is going to differ based on the application and the problems that we're trying to solve. I think the way that I like to think about it and the way that I've seen it explained several times is not about it does only one thing. It's that it's got one reason to change. And Uncle Bob actually talks about having one actor to change it. But it's got one reason to change. And I like what you said, Elliot. I would scale that even further. I feel like single responsibility principle is something that's grown with my career. It starts with single responsibility at a function and a method level. We can talk about it at a microservice level. But you can also talk about it at an org design level. When we're talking about structuring teams, custodianship models, again, things that change together should stay together. That was David Parnas, but I really like that as a bit of a principle to live by in our space. But that single responsibility, having one reason to change. Systems should have one reason to change. Ideally, I could look at teams and say, well, they should really only have one reason or a cohesive set of reasons to change.
Interesting.
Yeah, I feel like that saying has become things that stay together, things that change together stay together. I feel like that almost every time I'm making a decision around where I should write code or how I should write code, that question pops into my mind, and it almost always pushes me in directions I might not have gone otherwise.
Could people do it the other way around, where people say, well, things that are staying together should be changing together, and then that can cause problems in the code, right? They're like, well, these things are together, so now we need to try and like...
the actor thing, I think, is the best way to think about it. It's like, how many different things could change that would propagate change to this thing? And you want to reduce that number as much as possible. And I think like clean architecture, I don't know all the architectural patterns in the world, but something that stands out significantly for me with clean architecture is the idea of making all your business logic technology agnostic. It's like applying single responsibility at the macro level to your actual application itself, not just the functions or components or modules within your code base, but the actual business logic itself. That its single responsibility is to achieve the business outcome, not to do HTTP, not to do Lambda stuff. And so one of the big things about clean architecture, I think to me this is the thing that makes it stand out from a lot of other ones, is that level of separation, where you make your business logic technology agnostic and completely rip out anything that's concerned about what platform it lives on.
Yeah, there's definitely a anti-pattern, I'd call it, that I've seen in, various repos across the years where you've got business logic and then it's tied directly to, say, HTTP errors, right? So you've got, I'm going to go and get this thing from this API, and you're like, great. And then it goes all the way down to whatever repository level where you're trying to pull something out of some sort of data store. And it says, oh, the thing doesn't exist. I'm going to throw a 404. And it's like, why does that data layer know what a 404 is? Like, it shouldn't know where it's running. I could be calling it from a Lambda. I could be calling it from, CLI, like somewhere where 404 isn't a thing. And now we've inherently tied the concept of a HTTP error to an underlying database technology. And you're like, that's not good.
I think that's a great example. It's not always possible to decouple ourselves from frameworks, as it depends on the language and the paradigm we're within, but we should always try to create that boundary. And just an example of what you just mentioned, to put this into a real world example. So I remember it was a couple of years ago, SEEK actually changed their technology strategy to say, in terms of a preferred node framework, we're moving from Express to Koa. Now, all of our applications within our space had been modeled taking a lot of inspiration from clean architecture. I migrated a couple of those repos myself. It was half an hour's worth of work because we had clearly separated that delivery system from our business logic. It was swapping in and out the dependencies and changing a couple of response and request objects and done. There are repos that are still using Express here today in production because to unwind how deeply that framework is coupled through request, response objects, error objects, all the way through the code is just simply not possible. It's basically a rewrite. So you might say, well, how often do these things happen? And I can give you like that's a great example. I've got some other examples where we've swapped out persistence layers. Other examples where we've either broke out into microservices or either combined microservices together. And having these levels of separation and these clear boundaries makes all of those things not completely trivial, but fairly straightforward. So maintainability, evolvability, testability aside, there are some great examples when it comes to big change that having these principles implemented in our code make those things really easy.
We actually, Seamus and I just did a refactor on that because there's an anti-pattern that really drives me nuts, and that is the catch and log anti-pattern. If you catch an error, log it, and then rethrow the same error, or destroy your error onion and throw a completely new error that's blank, it drives me nuts when I see it. And we just spent time to rethink how the pattern we want to apply for our error handling middleware and our APIs. So it's very much because there was the example of one of the layers really far down was throwing a very specific type of error that was tied to Koa. And I'm like, it shouldn't know what Koa is. It shouldn't care. It should just be throwing a domain error that says, hey, I can't find the thing you asked me to find. And that should bubble up to someone that can handle it. And if no one can handle it, it should bubble up to your translation layer on the outside of your API. The thing that says, hey, you've thrown a not found of this type of domain error. Well, I know it's a not found, so it's a 404. But that's really closely coupled to the Koa layer. Everyone else in between doesn't know what Koa is. they know what the domain error is, and they may choose to handle it. They may not. They may just say, oh, it's, is instance of domain error. Don't care. It's somebody else's problem. It's not my responsibility. But I've caught that and checked, is it something that I care about? And I've said, nope, it's not. And off it goes.
It was really my understanding of clean architecture that highlighted that was a problem in the first place. Seeing that there was technology embedded down deep in our entities, it's definitely a much better outcome. I wouldn't have seen this issue if you obviously saw it on your own as well, but I wouldn't have seen this issue if I wasn't thinking with clean architecture, looking at the code from that lens. And you, one of you asked, or maybe Adam brought it up, the problem of when does that ever happen? When does technology change? When do you actually deal with the consequences of moving from one framework to another? And I get asked that question often when I'm talking to someone about clean architecture for the first time, when I'm talking about that separation of technology. Because it obviously comes with some overhead. We have to build a middleware to translate from your domain error into your HTTP error. So there's obviously some overhead related to that. And so people naturally are going to be like, I don't see the benefit in, if it takes 3 years before that incident happens where we're changing frameworks, think about how widespread the overhead is of building this extra functionality. And I've always been surprised that question gets asked by more experienced engineers, because I would have thought that they would have encountered it, and maybe they haven't, but I have. And when you're in that position, it can be one of the most profoundly challenging things to work through, is moving from one framework to another when your entire application or all of your applications, if you own a handful of APIs and a bunch of workers, if they're all built with that, without that separation, it's not just the one service, it's all of them. And you can't really predict how the organization is going to change, how your team's going to grow and split. Monetization used to be a team of 10 or so engineers, and now it's 50 split across 3 or 4 different teams. It's not just about technology, but it's also about ownership. Because of the way that we think about clean architecture, we've modeled some of our APIs. Some people might have thought of them, Will was saying before, as separate services. They're domains of concern within the API, like merchandising. Audience is probably not going to understand these terms, but there's an API, it serves more than one responsibility that are somewhat tightly coupled. But because we've designed it in a way that completely separates them as domains of concern, as well as from technology, not only if the technology changes is it going to be easy for us to pivot, but we can actually pull that module out into another service very, very trivially and literally copy and paste the entities that it shares into this new service, and everything will work. There's no extra overhead in doing that change. And if you don't have your system architected with that level of separation, you basically just make the choice not to do it. You just live with this legacy thing until it gets replaced, which is not a great place to be in.
Well, let's take that back to sort of a fundamental level, which is there's studies that have been done that sort of suggest sometimes it's 10-1, sometimes it's 80%, but the point here is it's a vast majority of our time as engineers is not spent writing new code. It's reading code, it's comprehending code, it's understanding what's been done before us. So if we can optimize that reading code, even just a little bit, it's going to make us a lot more productive as engineers and engineering teams. So that's one part of the fundamental side of why some of this is important. The other part, and you mentioned it, Seamus, is change. There are a lot of reasons for change. There's obviously the product and the feature changes that might come in, but technology changes. Dependencies will change. Frameworks may become redundant or obsolete. People will change. Teams will change. Performance considerations will change. Security considerations will change. There's a lot of reasons for change. And it's very unlikely that whatever we build today is not going to go through some series of change over the next months or years. And so when we have some level of confidence that I know that this system is going to change over time, that's when these become more and more important. So, well, how am I going to structure my system so that I can optimize for that change moving forwards, knowing that that's going to be more expensive than the time I'm going to spend building it right now?
Yeah, maybe those people you were saying who senior engineers who haven't experienced why do we need to do this? Maybe it's because they're going from project to project. Just we need to upkeep this. Then we find another project.
Yeah, that's actually, you've just reminded me that one of the staff engineers in our team, he reached out to me recently with like links to repos, being like, "What architecture do you think this is? Like, how would I, how does this compare to clean architecture?" Like, I'm trying to map the differences in my mind. I think the people that I've heard that question from, they can be very experienced engineers. Like, I'm thinking of one person in particular who worked for Harvard, and I always looked at this person as like a paragon for engineering. They work on projects that have like 2 or 3 people on it for a year or 2, but it's like it's not going to be subject to these changes. There's not going to be a massive shift in the company. There's not going to be a big shuffle up. They will just live with the legacy because it makes more sense to just keep building on what they have rather than replacing it. It's not a big business mindset. So you're probably right. It could just be the people that are asking me these questions happen to have worked on projects and contract work, hop from project to project, that kind of thing. But when you work somewhere for 5 years, you see it. Eventually, you're going to run into it.
You've just implied something there, which is really important that I think we haven't touched on at all, and that is trade-offs, right? So the trade-off there, which was implied, was if it's a team of 2 or 3 people and this system is only going to live for a year, the trade-off is we're not going to do this upfront thinking and planning to make it single responsibility and reusable and easy to change because we don't care, because in a year's time, it's gone. Whereas the trade-off being, if this code may be here for 5+ years and we have to go and change it later, if we structure it right now, later is going to be much, 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 much easier.
Would you trade off clean architecture for speed?
Excellent question. So there is a great article by Martin Fowler on the cost of quality code, something around that. I won't get the name perfectly right, but if you Google it, it will come up. And what's really interesting about that is he talks about the internal quality of code and this idea of craft and technical debt. But there's this idea that, and hopefully this doesn't surprise anyone, that if we invest more in the architecture and the quality of our code, over time we should be able to deliver incremental value more efficiently, more effectively. So over time we end up with, in the same time period, we'll end up with more value delivered versus one that doesn't have the same level of internal quality. The surprising bit is that he suggests, and from my experience, I agree with this, that the inflection point or the crossover point at which the well-architected system overtakes the not-so-well-architected system in terms of something might have optimized for speed is actually weeks. It's not months. So with that in mind, I would always be considering, like, there's no right solution here, right? There's a million different ways. There's an infinite number of ways we can architect our systems. There are some great ideas. There are some that don't work so well. I'd probably say that the only bad architecture is one your team doesn't understand, and then anything beyond that is going to bring some level of value. But if you have some concept of your roadmap and looking forward and go, this is actually going to live for a short to medium to long period of time, and there's highly likely that I'm going to be making changes to this more than just a couple of weeks, a couple of sprints, then investing in some level of clean architecture or just the architectural principles is very likely to pay off within a short period of time. If it's something that I was creating, say, to respond to an immediate need or incident that was going to be something that we run once or twice over the next couple of weeks, sure. Like there's the trade-off for speed. We might do that. But if anything's going to be even short-lived and require some level of change, introducing some level of clean architecture and those principles is probably going to pay off.
You touched on something then that I want to reinforce. This is something that I always say to teams when I'm talking to them about clean architecture and they're asking about, they may be interested in introducing it for themselves, which is the most important thing is that the team understands and agrees on what the architecture is. Because if you've got one person saying this is the gospel, this is the way, and no one else understands or is refusing to understand for whatever reason, if they're resistant to that, then all the hopes and dreams in the world aren't going to get you anywhere. The most important thing is that everyone's on the same page. And that doesn't mean using clean architecture. Maybe that is maybe it's an architecture that you make up on the spot, whatever it is, as long as the team all agrees and understands the mentality behind it. And then kind of to the side of that, I would say the other most important rule is solid. So as long as it's adhering to solid as much as possible and you're keeping those principles in mind, the next most important thing is that the team all agrees on what the architecture is.
Yeah, I mean, what's architecture about? It's communication, right? It's us communicating the intent of our code, the purpose of our code. It's really about communication, and that communication involves others, It involves the team. So you're absolutely right. We need to get on the same page. It's probably the most critical part. Can I bring us back to the experience? I think there's an interesting question. Sorry to loop back, but you mentioned sometimes it can be challenging to explain to team members that maybe don't have that level of experience. And I want to touch on that because it's really important. It's not, in my mind, it's not about knowledge. It's not about team members not having enough knowledge. But I would say the biggest barrier to introducing these sorts of concepts to teams is that experience. If you've got people that have worked on code, legacy systems, or seen systems evolve over years, devolve over years, it's often pretty easy to convince them that these are good ideas because they've seen that pain. If you are working with team members that maybe are new to the industry or, like you said, have hopped around a number of different companies and not been there to see some of the pain that decisions can really create on a business, it's a lot harder to convince them of the value here because they just haven't lived it. So for me, in terms of what's one of the biggest challenges to introducing this to teams, it's actually that experience level. So again, not knowledge, but their experience. Have they experienced that pain? They'll probably pick this up pretty quick. If they haven't, you'll probably get those sorts of questions around, well, this is going to take us longer. I don't quite understand. Why am I investing in this? Why do I need to read this book? And it can take a little bit of time to convince them of that. And again, that's often just through their gained experience. If you can take them through some of those advantages, and Seamus, you mentioned some recent ones in the team, and they see this happen, like, oh wow, okay, so this is what this is about. Like, this makes these things so much easier. I can now see this value.
Yeah, I like that you mentioned that because I've used that technique as well, where you're framing it in the context of the things that people have probably experienced, because not a lot of us have seen Nirvana, none of us have seen utopia of what these textbooks talk about, but most of us have experienced the inverse, right? And I think I'll just pull up the presentation that I stole from you a few months ago. Some of these terms like coupling, cohesion, the other ones, I can't remember off the top of my head. That's the thing, is these words almost lose their meaning sometimes because they just get thrown around and used. And I'm going to add some more to your vocabulary. Some of the ones that we use, like rigidity, fragility, immobility, viscosity, needless repetition, opacity, needless complexity. They're like the inverse terms of things like cohesion and coupling and stuff like that.
Yes, you've heard me talk about these many times, but that's exactly right. It's hard to convey the benefits. It's a lot easier to convey the pain points to engineers because it's very likely that even junior engineers have worked on systems that they found really fragile, very rigid, hard to change, that they find it difficult to adhere to the principles or what's been set before them, that they find difficult to understand. So if we lean on that a little bit, often lands and resonates with the engineers a lot more. So it's not so much about this is what we're going to get, it's this is what we're going to avoid.
Yeah, think about every university project you've ever worked on.
Please no.
We've all been there. Everyone's been there. So we kind of already talked about, for teams starting out, what steps would you recommend to transition to clean architecture? That's kind of what we're talking about present the problems that it solves, present the pain, that kind of thing.
Yeah, and probably just the other point to add there is this is not an all or nothing, right? This is not like introducing a massive framework. It's not a set of rules. These are principles, practices. You can start small and you can evolve it. I've worked on large legacy systems that have been horribly coupled with some awful frameworks that I would never suggest anybody use. They were great for the team because they understood it and they got them to a point, but we could introduce these principles step by step. So we can start to identify what are the business rules? Like what are the entities and the domain objects that we really need to care about? Let's isolate those from the external details. Let's remove some of the coupling to, say, the database models, which you'll often see, particularly with like active records and these sorts of things. How do we start to decouple the delivery system or the front end frameworks and some of those request and response objects? And so you can certainly start to build these patterns into a legacy system by starting with what's most important, what's adding the most value to your system. Well, it's the business rules. So let's start by isolating those, getting those well tested, and going from there.
Yeah, something that I've learned over the years is that it's not a blueprint, right? It's not a silver bullet, doesn't solve every problem, but it's definitely not a blueprint. Everyone's got their own interpretation of what it looks like in practice. When you actually put code pen to paper, when you put hands to keyboard, code to CPU, it's everyone's got a slightly different interpretation of what that looks like.
Well, this is one of the contentions. I see this a lot. It comes up a lot. It's like, okay, so I've read the book. I've read the blog post. So what? Sounds good. Tell me how to do it. I think we've got to, we're engineers, right? Our primary role is to solve problems. Good engineers will solve problems in more efficient ways that continue to evolve in a more effective way. Like we said before, those problems are really about communication. But, where was I going with this point? Remind me.
Engineers solve things in different ways. We find we have different interpretations of what clean architecture looks like.
Yeah, that's right. So I think we need to move away from this idea that tell me how to do it and I'm going to copy it. This is why I'm very wary of like templates or boilerplates. There are plenty of clean architecture templates out there in multiple different languages. I'm not saying they're bad. They're not. They implement a lot of these principles really well. What is dangerous is when you just copy that or try to extend it. So imagine trying to extend a to-do app to one of the core systems that the monetization teams manage. It's very unlikely to get a good result. You really need to start with domain-driven design, understanding your domain, how you're going to communicate it, how you're going to talk about it, and growing from there and using those principles. So, I think engineers will often default, well, just show me how it's done, as opposed to, well, let's solve the problem. Let's take those principles. How would I apply that to this problem? Because this problem is likely different to other ones you've had before. There are some things that are going to cross over. So that's one of the criticisms I see a lot. Now I just want to challenge that a little bit. It's not a rule book. And if it did, I'd imagine it would be a lot less valuable. Let's say Uncle Bob had done that and had a whole bunch of examples in .NET. You'd probably have Java developers saying, I don't think that's very valuable. You have TypeScript developers going, well, that's not for me. It's only about .NET. So having it principles-based means we can apply to any problem, any paradigm, any framework, any language, and should, again, hopefully stand the test of time.
Are there any patterns in the Uncle Bob's book which have evolved past what is written? Like, are there any chapters in there which you would read now and be like, well, nowadays we would kind of think about this a little bit differently?
Fantastic question. I wouldn't say that it's necessarily evolved past that. I personally think that the principles that are presented there are really sound and that they do scale. But my understanding of those and how to apply those has definitely evolved. I've seen in the community the way that these have been applied and communicated have evolved quite a long way, actually. And so I won't say that the practices or the foundational principles have necessarily evolved, but certainly the way that we apply them and the way we understand them. And you've got to remember that the book is 12 years old. Oh, sorry, it's not 12 years old. The blog post is 12 years old. The book's about 8 years old. I'll probably get that wrong, but somewhere around there. Think about how much change we've seen in our industry over that time. The way that we deliver, develop software, scale software now is very different to what it was 8 years ago, very different to what it was 12 years ago. But I don't see these principles being any less applicable. And when you think as well about decoupling and I mean, Uncle Bob does talk about deployability as well. So deployability, well, now we're in this world where scale is a big thing and microservices are a big thing and containerization is a big thing. Like, these all help or can help us to deliver software in that way more effectively, because if we do have these things that are decoupled and independently deployable, it obviously I think it lends itself really well both to agile and our way that we deliver software these days, but also the way we deploy software.
And do you have any other books, resources, etc., to learn more of these things apart from the clean coding book? anything more recent as well that maybe touches on some of the more recent practices?
Should we clarify, because this happens, I find this a lot, is there's clean code, and there's the cleaner code or clean coder book.
That's right.
And then there's clean architecture.
That's right.
So clean code is about like on the micro, it's how like line by line how you make your functions cleaner. Clean architecture is it's not actually related. They're both great ideas and they're both fundamental to the way that I think about code, but they're not coupled ideas.
They're related in the sense that it's all about us communicating our intent through our code better and more effectively. They're just at different levels of abstraction. And then Clean Coder was sort of the book that came between, which is a little bit more focused on practices and that sort of thing. So outside of those books, which I would recommend everybody read, and these are reference books, right? You don't have to read it cover to cover, but they're reference books. They are great books. There's probably a few I'm going to think off the top of my head here, but Khalil Stemler has a blog series on clean architecture, which explores some of these in depth, which I think is an interesting one. I'll probably get the name wrong, but it's Tom Thornburg has got it's something I quite like the title. It's something like Getting Our Hands Dirty with Clean Architecture. It's in Java. It's focused on Java, but a great book that explores some of these. There's also a very short one, a Code Opinion. I'm going to forget the name of the host, but Code Opinion, I saw it relatively recently, has a YouTube video where he explores in .NET some of his thoughts around clean architecture, having had some feedback say, hey, well, why don't you use clean architecture, or why have you used some of these things here and not there? And that's actually quite an interesting 10-minute video where he just goes through some of his thoughts on what he thinks is valuable, what he's not. But I think it's a great resource too, because it's another software engineer talking through their experience and lived experience and what's valuable and what's not, and how he applies some of those principles and where he makes some trade-offs in terms of, well, actually I'm probably going to lean more heavily on a framework in this instance, or I'm going to lean more heavily on this. And I think that's a really interesting one as well.
Yeah, personally, I would recommend the book, like the book by Uncle Bob. It does have a subheading, but literally, if you just look up clean architecture book, it's you'll get 10 of that result, the same book over and over and over again. I know that there are other books. I've seen that there are books that are essentially trying to teach you how to practically apply it. But like Adam said, like we said before, I think understanding the principles is the most important thing, and then kind of working out a model for yourself.
I'd probably recommend as well, and Seamus has seen this many times, probably Elliot as well. So I've done a number of presentations on this before, and I often start with a bit of a history that leads up to clean architecture. And we touched on some of those architectural ideas earlier. Research those. Like, that gives you a really good insight. They were solving specific problems at that time. It gives you a great insight into, so that's how they were solving that problem. That's why they were solving this problem. And like we said earlier, clean architecture is really, and I'm not trying to discourage, I guess, Uncle Bob's work here by any means, so don't get me wrong. But it is a combination, evolution and all of those. So understanding some of those and the history that led up to that point, I think, is really important. So those are definitely valuable things to look at in terms of resources. And
just for anyone listening, if anyone wants to go out and read about those, some of those ideas are Entity Boundary Interactor by Ivar Jacobson, Onion Architecture,
Jeffrey Palermo,
Ports and Adapters Architecture,
Alistair Coburn.
See, there you go. I don't know off the top of my head. And then obviously MVC, MVP, MVVM, which is like separation of view, that idea.
I had one more question, because I was never given the answer for it. Why is your picture a horse with a hat?
Yeah, great question.
I'd love to throw that question back at you and say, well, what's wrong with having a horse? It's a dapper horse, right? So for those that you're not going to be able to see this because you're listening, my Slack profile picture is a horse with a fancy hat and a vest. It's a dapper horse. I can't give you a great answer to that. So actually I can. I don't want to give away my gamer tag here. It's related to my gamer tag. And when I started at SEEK and they said, can you put a profile photo up? And I'm like, I don't really want to put a picture of myself. I'm an engineer, just let me do my work. That's how I felt at the time. So that's what went there. It's a fancy horse. I'm like, okay, I've evolved from a gaming horse to a horse in corporate. So it's a corporate horse.
There you go. You know we're at the end of the podcast when we start going on diatribes about anything and everything. Awesome. Thanks for joining us today, Adam. I've really appreciated talking to you. I mean, I've been able to chew your ear off about this for the last 6 years, so it's good to be able to share that with other people. Yeah, and we sit near each other, so he doesn't escape from it either. And I'm in early enough that there's no one else, so he walks in, puts his laptop down before he's even sat down. I'm like, I've just got a thing I need to talk to you about. This thing about clean architecture, please. I need your insight.
This is true, but those are some of my favourite parts of the day.
Same.
I love talking about this stuff. I'm very passionate about this kind of thing. So yeah, thank you very much for having me and giving me this opportunity as well.